हेलो एवरीवन एंड वेलकम टू अरे। आई होप आप सभी लोग अच्छे होंगे और मस्त होंगे। दिस इज वीडियो वन ऑफ आवर IBPS SO प्रोफेशनल नॉलेज सीरीज. If you are preparing for IT officer, this section is the single biggest differentiator in prelims. Professional knowledge carries 50 out of 125 marks in prelims, more than English, reasoning, or quant individually. And in mains, it decides your final merit almost entirely, since other sections are just qualifying. Here's how the series works. We start from true basics and build up towards the advanced level. Today, we'll start with foundational topics. These sound basic, but they show up almost every single year, usually as direct questions, and they are pure memory plus logic, meaning they are free marks if you know them. Computers are classified into five generations based on the core technology used to build them. IBPS loves asking which technology belongs to which generation. So, the key is not just knowing the years, but the defining component of each generation. Go through all the bullet points on your own, and I will just summarize it for you. Think of this generation as computers as big as a room, doing less than your calculator. ENIAC alone weighed about 30 tons. The exam relevant fact to lock is vacuum tubes is first generation. Transistors were smaller, faster, and more reliable than vacuum tubes. This is the generation where computers became usable outside of pure research labs, mainly by businesses and universities. Exam hook, transistors is second generation. Also, this is the generation when COBOL, Fortran, real programming languages appear. This is a huge leap. Instead of individual transistors wired together, you now fit many transistors onto one chip. This generation also introduces something exam relevant, the operating system as a concept, and the shift from punch cards to keyboards, monitors. Microprocessor is the reason a computer fits on your desk instead of in a warehouse. Exam hook, fourth generation is microprocessor. Intel 4004 is the standard first microprocessor. This generation is defined by capability, AI, rather than one specific physical technology. This distinction between hardware defined generations 1 through 4 and capability defined generation, that is fifth, is itself something IBPS has tested indirectly by asking which generation is not defined by a single hardware component, and the answer is fifth generation. This is a quick memory hook to help you revise. Now, the second core topic, number system. This is frequently tested foundational topic in IBPS SO because it underlies everything else. How computers store data, how memory addressing works, how networking, IP addresses, subnetting works. Kindly go through this and understand. Binary is the native language of computers. The four number systems, decimal, binary, octal, hexadecimal. Notice hexadecimal has 16 digits, but we have only 10 numerals. So after 9, we use letters. A is 10, B is 11, C is 12, and so on till F. Now, conversion 1, binary to decimal. Each binary digit position represents a power of 2. So here the binary digit given to us is 1011. We have written 1011. Now, starting from the rightmost, this digit will be multiplied by 2 to the power 0, then 2 to the power 1, 2 to the power 2, 2 to the power 3. So we have written its equivalent. 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, and 2 to the power 3 is 8. Now we will multiply it. So 1 will be multiplied by 1 here, 2 will be multiplied by 1, 4 will be multiplied by 0, and 8 will be multiplied by 1. So it is written like this. Now we will add it. 8 plus 0 into 4 is 0. So this will become 0. then 2, then 1. So this is 11. So 1011 is actually 11 and it is written in binary. I hope this is clear. Now, here is another example. Convert 11001 to decimal. Pause the video, do not look at the screen and solve it on your own. We will look at the solution. So write all the binary digits and then assign 2 to the power starting from rightmost. So this will be 2 to the power 0, then 1, and we will go on till all the digits are covered. Now we have written the value of 2 to the power. This is 1, this will be 2, and then we will multiply. So 16 into 1 is 16, 8 into 1 is 8, 4 into 0 is 0, 2 into 0 is 0, and 1 into 1 is 1. So this is 25 in decimal. I hope binary to decimal conversion is clear. Moving on to conversion number 2, that is decimal to binary. So just the opposite. So now we will convert 25 to binary. So how this works? We will divide the decimal by 2 till it becomes 0. So 25 divided by 2 is 12, and what is the remainder? 1, because it is a odd number. Then 12 divided by 2 is 6, remainder is 0. 6 divided by 2 is 3, remainder is 0 again. 3 divided by 2 is 1, remainder is 1. And 1 divided by 2 is 0 because 1 is less than 2 and remainder will remain 1. So we will read it from bottom to top. So this is 11001. So 25 in decimal is written as 11001. And this actually matches our example. See the previous slide. Here it was 11001 and we have converted it to decimal. So 11001 is 25 in decimal and now we have converted it back. So it matches. That means it is the right answer. Now convert 60 to binary. You have to solve it on your own and I have given the solution at video's end. Now conversion 3, binary to octal. So we will use a method called hexadecimal. This is a shortcut method because 8 is equals to 2 to the power 3 and 16 is equals to 2 to the power 4. So we will actually make group. Now since we have to convert it to octal, we will make a group of 3. So starting from right, 011, this will be group number 1 and 101, this will be group number 2. So 110 is what? It is 6. How? We have already seen binary to decimal conversion. 2 to the power 0 into 0, 2 to the power 1 into 1, that will be 2, and 2 to the power 2 into 1. So 4 plus 2 is 6. We have already seen this. Here we have only converted binary to decimal. And again, 101 from binary in decimal is 5. So octal has become 5, 6. Okay, so don't confuse. What we have done, I will repeat it again. The binary number we have grouped in threes starting from right. So this is group number 1, 110, and 101 is group number 2. Then from binary we have converted into decimal, which we have already seen. And this is 5, this is 6. So in octal it is become 56. Now, many of you might think, so this was 6 digit. That is why it got converted easily into group of 3. What if the digits are not a multiple of 3? So our next example is based on that. Convert 1001 to octal. So what we will do, we will pad with leading zeros to make it 6 digits. So original was 1001. We have added 2 zeros. Okay. Now it has become 6 digits. We will now again group in threes from right. So it will be 001 and 001. What is 001 in decimal? It is 1. And again 001, 1. So answer is 11 in octal. I hope it is clear now. Conversion number 4, binary to hexadecimal. Now in octal we have converted group of threes. Now we will convert in group of fours. So again, this is a 8-digit number. We'll start from right and we'll make a group of 4. So 1010 will be in group 1 and 1011 will be in group 2. Now what is 1011 in decimal? It is 11. Now you have to solve it on your own how this binary is 11 in decimal. And 1010 is 10. Now in hexadecimal, we have already seen after decimal line, alphabets get assigned. So A is 10, B is 11, right? So A is 10 and B is 11. So this is the answer, BA. Moving to another example, you solve it on your own and I have given the solution at video's end. You have to convert it to hexadecimal. Now conversion number 5, decimal to hexadecimal. So convert 202, which is written in decimal, to hexadecimal. Now for hexadecimal, we will divide by 16. So 202 divided by 16 is 12 and remainder is 10. Okay. 12 divided by 16 is 0 because 12 is less than 16. So remainder is entire 12. Now we will read bottom to top. So CA. So 202 decimal is CA hexadecimal. I hope this is clear. Now, binary arithmetics basics. Binary addition rules. 0 plus 0 is 0, 0 plus 1 is 1 plus 0 is 1 plus 1 is, you have to write 0 and you have to carry 1. And 1 plus 1 is, you have to write 1 and you have to carry 1. Now, we will see one example. You have to add 1011 and 1101. Okay. So 1 plus 1 is 1 0, you have to write 0 and you have to carry 1. Then 1 plus 1 is again 0 and you have to carry 1. Then again 1 plus 1 is 0 and you have to carry 1. Now there are 3 ones. So you have to write 1 plus 1 plus 1, which is you have to write 1 and this is the carry forward one. So this is the explanation. Addition is simple. You just have to know the basic. Now you can also check. So 1011 is 11 in decimal and 1101 is 13 in decimal. So 13 plus 11 is 24 and our answer was 11000. If you'll convert this, this is again 24. So this matches. So you can also check. You can convert the binary individually into decimal and then check whether your answer matches. Keep practicing till it becomes a habit. It is not very difficult and I have told you every method. Just keep on practicing and you will be able to solve it very easily. Now binary subtraction rules. Here 2's complement gets introduced. We will learn what it is. You just read these 3 steps and try to understand. I will explain with the help of an example. Now this is the example 1101 minus 0110. So this number we have to subtract from this. So whatever it is written after minus, that gets subtracted and you have to calculate 2's complement of that number. So since after minus 0110 is written, we will find its 2 complement. Now how do we find it? First you have to flip the bits. So 0110, just swap it. 0 becomes 1, 1 becomes 0, 1 becomes 0 again and 0 becomes 1. So this is the first step, flip the bits. Now we have to add 1. So 1001 plus 001. You know the addition. 1 plus 1 is 0. 1 gets carried. Now 0 plus 0 plus 1 is 1. 0 plus 0 is 0 and 1 plus 0 is 1. So we have added into 1001. So this is 1010 and this is the 2's complement of which number? 0110. So how is 2's complement calculated? You first have to flip the bits and then you have to add 1. So now we have calculated 2's complement of 0110, which is 1010. Now, how does the subtraction work? We actually add it to 1101. So 1101 plus 1010. Now you do the addition, and just one more thing, you have to discard the leading carry bit. So I will actually tell you 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1. So what it is? It is 0 and a carry forwarded 1. So we have to discard it. In subtraction, just remember this was the rule, the step number 3. Discard any overflow carry bit. So in this number, this one was carry forwarded. So we have to discard it. So what is the result? 0111, which means 7 in decimal. You can also verify how. Convert this into decimal, convert this into decimal, and check whether 7 is coming or not, because our answer is 7. Now, third important topic, data units. Bits, bytes, and data units. Important, you should know the value for each unit. So this is the solution of both the questions that I gave you earlier. Just check it with your answer. So here video 1 is completed. Next video, we move to computer architecture and the booting process. If you like the video, please do hit the subscribe button. Thank you so much.